All right, guys. So now today, so let me open up a cheat sheet. So let's say, so what we have done is that the areas of a data science, right? Maybe let me flash it out. We were looking at areas of a data science. You remember in the beginning in the introduction class. So this is what the the data science, structured data using machine learning. In that, we have completed classification, regression, and also PCA, which is not mentioned here. So we're not going to touch on all the other this thing because they're all again ocean of big things. So that's why now we just color coded. We'll be doing the projects on 4 areas. So every area will take a month time. So it can be taught for 1 full year. But looking at the more job openings and all, yeah. So only few e-commerce companies. Now what happened is this recommendation market basket analysis kind of thing. A lot of products are already there. So people are using the products rather than hiring data scientists and start building new products. So that's why, and these are all small things actually. So the bigger projects, even if you go to any of the industries and all, the classification, dictation, or the enormous number of opportunities are there. Okay. So now we also covered PCA, which I have not mentioned here, principal component analysis. Those three are very detailed. I would say reasonably we covered. Okay. And we have done two projects with the PCA. So now we are moving to the unstructured data image classification. So when we say unstructured data, right? So this is nothing but, so from today to, we are starting artificial intelligence actually. So basically, this is also an artificial intelligence. So people can see that we have an artificial intelligence system to predict the house prices. So, but usually, the name artificial intelligence suits more better for the unstructured data. So that's how this one. But anything in the data science spectrum, you can say artificial intelligence. But usually people choose in this area. So now image classification, video classification, speech, and NLP. So these four are the areas comes into the this thing. So now I'll give you one example. Actually, in order you to understand. So let's go here. I'll take a example as a big project, but we'll be starting a smaller project. Okay. Kaggle, distracted driver detection. So I don't want to again teach so much of a theory and all. Let's so it's as simple as that. What is artificial intelligence solution actually? Okay. So this is one of the very, very widely used for the insurance companies. And this is what about $65,000 project or slash competition. Okay. So what is this project says that? So let's go to an example. So before we go a lot of theory, let's understand this one. Okay. Let's say, what do you call as Dinesh. And then, what do you call as, let's say somebody posted the chat, right? Who is that? Praneeth. Okay. So now just think of this one, Praneeth. Okay. So now, or maybe let's put it this way. Okay. You both own Honda City car, Honda City of same variant. It is bought in 2021 and it's also bought in 2021. And you both drive in Hyderabad. And Dinesh is age of, I'm just giving some number. What do you call as everyday average of 40 kilometers, maybe miscellaneous, and again average. Okay, 40 kilometers driving. Okay, 40 not kms, ms. Okay, and what do you call as maybe even you say both are of 30-year-old. I'm just throwing. I don't know what's your age. And then both have a driving license experience of 10 years of license experience. Okay. Likewise. Okay. And then what do you call as maybe this is your second car and this is also second car, assuming that. Now let's say these are the parameters you have. Now you are applying for a let's say maybe what do you call as State Farm, or maybe in India, you can say Reliance General Insurance. Reliance General Insurance. Okay. You are going and applying insurance. Okay. You are going and applying the insurance with these companies. Okay. Now the insurance company for Dinesh, they quoted 40,000 rupees as a premium per year. Now tell me guys, how much Reliance General Insurance is going to quote for Praneeth? Guys, now this Dinesh own a car, Praneeth own a car, both drive in Hyderabad, Honda City, 2021 model, 40,000 30 years of age, 10 years or whatever, driving experience. Second car, 40,000 is what Reliance General Insurance is quoted to Dinesh. How much they are going to quote for Praneeth? Guys, Umesh, Megha, Monisha, Megha, can you tell me, Umesh, how much Reliance General Insurance is going to quote for Praneeth? What could be the premium for Praneeth? Okay. I think same. Okay. Few other guys. Guys, I'm just giving you a hint. Okay. If you have understood the last two projects with PC and all, well and good. Even if you did not understand, just know we are going to teach in only in 3 sessions, like 6 hours or whatever. Maybe this week and next week, we can finish one deep learning project. Okay. Stay tuned, and I'm going to make very crisp. I know, because especially the deep learning people jeopardize here and all with neural networks, bias, this thing, that thing, perceptron, receptron, people makes you confused. But I just realized to teach you in a little bit different way so that you'll not be bombarded here. Rather, you get a holistic view of education. Okay. So if you just pay attention for a couple of classes, and you can finish one project here. It depends on the insurance history of the first car. Okay, good question. Assuming that the same history. Okay, assuming it's the same history. Question is valid, but yes. So, but after all these things, right? So they are going to quote the same for this thing. But what I wanted to say is that yes. So almost all the major parameters are same. And what could this one? So that's a 40,000. Yeah, Dinesh, your question is valid, but yes, it is same. But now this is the problem statement, guys. Now what all these insurance companies are thinking, okay, these are all structured data. I know the values and all, but the point is that, right, guys, whoever has joined in the last 2-3 minutes, yeah, we are discussing the artificial intelligence introduction and a problem statement in the last few minutes. Okay, guys. Okay. Now, for those who have responded, Dinesh, Harika, Praneeth, and everyone, yeah. Now that we're all in the distracted world. What do you mean by distracted world? When you're driving, you're texting, maybe you are in the high-tech city junction, that it shows 180 seconds of waiting time in the junction. Yeah, even not even I. So I also feel that 3 minutes of time, I open up my phone and check for some WhatsApp and reply to somebody. Even I open up my office Teams Messenger and respond to somebody. So yeah, we have a tendency of doing that, or maybe you take a phone call and this thing. And of course, we in India, we don't do a lot of coffee drinking while driving, but in United States or any UK, wherever the cold countries, people drink coffee a lot while driving. That's one of the very common this thing, right? And again, no seat belt could be possibility, or maybe what you call it, your kids must be sitting backside, you're talking to them. So what I wanted to say is that could be a possible, huge distraction with this current digital world. Okay. So for that reason, what these companies are, the guys, whoever has joined recently, we are discussing the artificial intelligence introduction and quick 1 minute of this thing. I say that the two persons having same car, same etc., and Reliance General Insurance, they applied and they quoted 40,000 for Dinesh. And what could be For the Pranit, yes, answer is the same thing, because the point is that the parameters are all same. But now the point is that, right, people are looking at these things. Okay, now let's go. This is the problem statement. This is the project. Okay. Now we have been there. A light turns to green. So State Farm is one of the very large and one of the topmost insurance company in the US. So they are looking at the distracted driver detection. So what's your thing saying that is that when you pass an offend driver, what you can say? You certainly aren't surprised when you spot a driver who is texting. So meaning that you are just harming somebody in front of you, but that guy is not moving, is blocking the way, and then you realize that he is texting. Then you get angry, right? So seemingly enraptured by the social media, or in a livelihood handled conversation in their phone, etc., etc. According to the Center for Driving, whatever the CDC motor vehicle, this thing, 1 in 5 car accidents is caused by a distracted driver. So out of 5 car accidents, 1 is happening only because of the distraction, not because of the not knowing driving or anything. Sadly, this translates to 425,000 people injured and 3,000 people killed by distracted driving. So 3,000 is a huge actually, right? 3,000 is not a huge, but just because of this distraction, these many people are getting injured and distraction, and these many people are getting killed. What if we are one of among them, right? So you have to think in that way. So that's a big number. So State Farm hopes to improve these alarming statistics and better ensure their customers by testing whether a dashboard camera can automatically detect. So what all these insurance companies are thinking is that they wanted to give a dashboard camera to you. So you'll be putting a small dashboard camera, and that is an IoT based camera, internet based camera. Every 1 second, while the vehicle is in movement, every 1 second, it will be, why I'll say 1 second, even in the parking, you do the, you put your car in the parking and go to office after come back after 10 hours, right? So that time we don't want that images to be sent. So while the vehicle is in motion or in the engine is on, something like that. So this 2D dashboard camera is sending your picture once in a second to the State Farm warehouse. Okay, every 1 second it takes a picture and send it to the warehouse. So what happens is in let's say you are driving 1 hour morning, 1 hour evening, assuming that, okay, 2 hours into 60 minutes, okay, into 60 seconds. Okay, so let's say for 30 days, you are driving, let's say 20 days, 25 days only, okay, leaving holidays, okay, hours per day, okay, minutes and seconds, okay. So now in a month average, how many images are going to be captured? Let's say this one. 1 second, bear with me, please. You go here and then there's this one, and then multiplied by 60 plus multiplied by 60. So about 1,80,000 images are going to be transmitted on a monthly basis to their warehouse. Okay. It's all I say that 25 working days, and every day average you drive about 2 hours of time and 60 minutes and 60 seconds of each minute, each second. So if your camera is transmitting 1 image per second, and if you go think of it, if you are going for a long drive and all, not a usual office or college or university, it can be even much more than that. But I'm just giving whatever. Maybe it can be 1 lakh or 2 lakhs. I don't care. So in that 1 lakh of images, or 2.2 lakhs of images. So I'll show you. I have done. So basically, what they have done is that they're giving the dashboard camera, drivers engaging in distracted behavior, given data set of a 2D dashboard camera images. State Farm is challenging Kagglers. Who is Kagglers? We are the Kagglers. We are using the Kaggle competition. That's why we are Kagglers. To classify, here also classification, but it's the image classification. Each driver's behavior. Are the driver attentively driving, wearing their seatbelt, taking selfies while their friends in the back seat, etc., etc. So all this is, the project is about, they'll be giving the dashboard images. Okay, you can go to the data, and here you say download. Now here there is no columns as such, like what you call as classification or regression. All you'll be getting these images. So look at this: coffee drinking, texting, reading, talking, texting and reaching behind seat, or maybe audio player, etc., etc. So these are the images. All they'll be giving is the images. So it's a huge data set actually. It's a huge data set. So I have downloaded. Let me go to the data. 1 second. Let's go to the data. Let me show you that how the data looks like. So you go here. So they have given a train data. So train data is what? Train data will be having the output. Here the output what they have given is that they have given output in the form of a folder name. So meaning that C0 means, so I have just downloaded only five images. Yeah, because it's a huge data. So meaning that he's a no distracted driver. So meaning that it's promptly driving. Okay. Now, what does that mean? It is in the C0 folder, assuming that in Excel sheet, this is considered to be as no distraction. Now, this is a classification 1. What is that was classification 1? IMG 822. You can also put it in this way. You can go to Excel sheet and you can convert this into this one. Okay. Image number and classification. Distracted classification. Because it is a test data, right? You should have an output. Okay. What is image number? 822. What is this classification? C1. What is that C1 means? Maybe let's look into this one. Look at that. What is that distraction? So texting. Okay. You can go here and say C1 hyphen texting. Okay. Now let's look into it. All are texting. Okay. Texting. Now let's go to the other folder. So I have downloaded only, for the classroom purpose, I have kept only, otherwise if we go and put everything. So this is talking. Okay. Now let's go other. So likewise, they have given, 10 different classifications. So 9 of them are distracted. 1 is non-distraction. So what is this? Reaching to the CD player, whatever the music system. So the point is that music system sometimes also can lead to accident. It's all subjected to our confidence and all. Many times people say, especially texting is a dangerous thing. Talking is not a dangerous thing. Okay. So now what is the other one? Let's go here. This one. Yeah. Coffee. Okay. So we may think that coffee may not be a problem, but what if the beverage is very hot? See, there is a slight distraction, right? Rather than not having a coffee in the hand versus having a coffee, there will be 1% of a distraction. It's not about the distraction. In case of something, having 2 hands on a steering versus 1 hand on the steering, at least definitely some portion of the distraction will happen. That is one. Second thing is that because of the hot beverage, we are all more worried about our dress, right? I don't want my dress to be messed up. In case of an accident, I'm okay to not to my dress to be messed up, but in case of not accident, I don't want my dress to be messed up. So that's how the mentality, right? Sometimes even, when I go for an interviews and all, I tend to not to wear the seat belt because, my shirt gets, wrinkles, right? So I know many of these, disciplines are different from the reality. So you go here, let's look into this one, right? This is like, something fell down. So this person is trying to reach. Okay, maybe, your earpods fell down. You're trying to reach to get the earpods. We think that is not a big problem or anything, but it can tend to yield to a problem. It can be a fraction of second, right? So whole and whole, what is that is, I give you this project. I'm giving you train data with a folder number. So if that is in X folder, you can consider that as a classification. Or maybe to somebody may give you like this. What is image 629? He can give you in the form of Excel also. Image 699, 690, 629, 629. Okay. Sorry, 629. What is this classification? This is C7. C7 reaching behind. Something like that. So I can give all the image number followed by the classification. Here, You will not have any 100 columns, 20 columns, nothing like that. There is only one column, image number and what classification is that. That's all. And this is going to be my train data. Okay. It can be in the form of a folder or it can be in the form of an Excel sheet. Now I'll say test data. What is my test data? Here, same thing. Okay. Here also my same thing. Let's go here. Let's go here. What is test data? Image 1001, 1002. And now what is a distraction? That's all is a problem statement, guys. Okay. You'll be getting the train data with the classification. You'll be getting a test data without a classification. So now you go here. Now I have a test data. So within the test data, they have given it in only one folder called images. So they did not give the bifurcation of the classified folders. It's only one folder. Within that one folder, I have image 32, 170, 201, 32, etc., 307, 1046, something like that. It has a mixture of, okay, it has a text talking. It has a talking with the right hand. The left hand talking, right hand. Maybe there could be some difference. Okay. Coffee drinking, reaching to the music system, texting, maybe combing, and something like that. Okay. So there are some distractions. The point here is that, right? They have not given. What is that? 32, 170, 201, something like that. 32, 170, 201, something like that. What is the classification? That's all, guys. This all is image analytics. Now the question is that with whatever the knowledge you have so far, maybe you have a .NET knowledge, Java knowledge, C++ knowledge, Python knowledge, or general knowledge, or some computer vision knowledge, whatever. Maybe you are already know something about neural networks, whatever it is. How can you solve this project, guys? First of all, is a problem statement clear, guys? Maybe in case whoever has joined late, you can also ask questions. It's one of the very, very, very interesting project. But obviously, I'm not going to do this project. I'm giving you this for an explanation. The reason is that this, for the business centric wise, this is a great project, but this has less patterns actually. This has less complexity. And I'm going to talk about cats and dogs. That is not a business centric, but that's super good for the learning purpose. So I want the super good for the learning purpose rather than business centric. Okay. Yeah. But anyway, I'll do one project. You can take this as an assignment or something like that. I'll give the code also, no problem. But maybe after you doing the, what do you call as homework. Okay, guys. Questions, please. Is the problem statement clear, guys? What do you mean by image analytics? So this is nothing but image analytics, or this is nothing but a computer vision project. So same thing. Okay, let's go and put it this way. So people mark this as, call this as like this. What is that? Flavor one. Flavor one. What is that? We have built computer vision. No. Image analytics. Distracted driver detection project. Flavor 2. Okay. It's a startup company said like that. Flavor 1. Let's say it's a little bit superior company. We have built what do you call as artificial intelligent solution for this one. Solution distracted driver detection project. Now flavor 3. That little bit now what do you call as the spelling mistake? Huh? Yeah, ignore spelling mistakes, guys. Okay. Let's say I'm working at Hitachi. So we have built state-of-the-art artificial intelligent solution to spot the distracted drivers. Okay. So it's the same thing. Somebody say that we have built image analytics, or maybe even the other flavor, maybe zero flavor. Okay. Copy paste. Okay. No flavor or zero flavor. We have built computer vision based distracted driver detection project, right? So somebody says that we built computer vision based on distracted project. Somebody says that we have built image analytics distracted driver detection. Next company says that we have built artificial intelligence solution to spot the distraction of the drivers. Now, even superior company, we have built the state-of-the-art artificial intelligence solution to spot the distracted drivers. It's all about, how can you sell your, application or solution with a lot of sugar coated. So that's the, power of what you call as sales and all. So in other words, it's all same except that how we are presenting is the matter. Okay. Any questions, guys, so far? Okay, let me put this. So this is how, when you go for an interviews or something like that, so this is how you have to flavor it. Okay. When is my flavor 0, flavor 1, flavor 2, flavor 3, something like, yeah, you can copy paste in your cheat sheets. Okay. Right. So now this is the, so eventually what is that you'll be getting is that you'll be getting images and train images. You'll be have to classify the test images. That's all is that helmetless driver detection. Now you go here, there is another thing, right? So what do you call as AI based car insurance, car damage detection. Okay. So these days, if anything, car meets an accident, right? Usually a person comes from the insurance company and look at that. Now, these days, what they're asking is that, okay, car gets damaged, you take the pictures and upload it to the, maybe not take this, one of these things, right? So you take the picture of this, you take the picture of this, you take the picture of this and all, just upload it to the your insurance company. No person has to come, and system will automatically detect whether this is a previous damage or history damage, or this is a new damage, this is a covered damage, this is not a covered damage. If it is a covered, how much is can be, see, a person is doing, why system cannot do it actually. So this is how the another classic example. All these insurance companies are going with the, what you call as, you take the picture. See, somebody has to come from the insurance company and take the pictures and do the assessment. If human can do it, why artificial human cannot do it? Artificial is nothing but that is what we will be building the solution. Guys, is that clear so far? Is the introduction clear? Dinesh, Harika, Praneeth. Umesh, is that clear? Saketa, is that clear? Umesh, I want answer from you. Umesh, is that clear? Saketa, is that clear? Any questions so far? Umesh, are you there or not? I'm just randomly picking, yeah, whoever is not responding. Sricharan? Hey, Sricharan, is it clear? Okay. All right, guys. Okay. So now this is what the where we are heading towards. Okay. Now the problem seems to be as simple, but it's very difficult, I would say. Okay. Now let's get some introduction of to the so we call this as a deep learning. See, actually machine learning came. Anything with unstructured data, we call it deep learning, right? But for the sales purpose, we use the word called as artificial intelligence based. Okay. So deep learning is nothing but a, you go to naukri.com, you go to linkedin.com, you'll also see AI positions and deep learning positions also. Sometimes people always say that, so let's go, you go here, let's say here, let's say LinkedIn. Okay. Yeah, you just see this one. You go here, not start post. 1 second. Let's say here, image analytics, or maybe let's say computer, sorry, artificial intelligence. artificial intelligence, right? So you'll get a lot of, director of AI, ML research, manager, artificial intelligence, etc., etc. You'll be getting head of artificial intelligence and all, right? So similarly, you'll also see what you call as a deep learning. Deep learning. Yeah. So director, still it says that research develop within the code, within the description and all, they'll be talking about the deep learning. Artificial intelligence engineering, within that inside, you'll say deep learning. Now you go and see that computer vision. Vision. Okay. Yeah, director of AI, ML, computer vision engineer. Okay, computer vision engineer, artificial intelligence engineer. Within that, somewhere they'll be talking about the computer vision and all. So what I mean to say that is that, right? So if anybody has a feeling that, sir, after 3 months, can I become, a super blown data scientist and all? So it is not possible at all. Yeah. So I wanted to speak the truth. It is not possible. The reason is that if you go here, right, how many areas, if a company is working on image classification, they're not going to work on, if you are in a project of image classification there for 2-3 years, and you will not be touching all these things. You will not be getting an opportunity to work on classification, regression, market basket analysis, image classification, video NLP. That's impossible. If that is possible, means it's only all you will be doing the use cases, POCs, POVs. That's all. You will not be doing a project. If you have to do a project, even after 1 year of experience, let's say you are working on image classification, after working on the image classification 1 year of a time, you will, kind of this regression classification will go away from your mind. So you cannot become a super specialized. It's like in a doctor. It's like a, what do you call, this is data science is like, hospital. In that, how many divisions of a doctors and all, this is urology, nephrology, neurology, cardiology, orthopedic, etc. So this is of such kind of thing. Artificial intelligence is a big thing. That's why in engineering also, right, you have a 4 year of a degree on these things. So everybody will not become an expertise on everything. Okay. You have to limit to where more opportunities are. So that's where, we have identified the more opportunities on these two things, and image classification, NLP, and we'll be working on that. Now, anything on the Gen AI, right? The chat GPT, Gen AI and all is based on the English only, the English text large language models, LLM. So that is an advanced LLM, Gen AI, and the prompt engineering is all next to the NLP actually. So that's only a subset of NLP, but that is a huge. Gen AI is huge. It takes another 4-5 months to learn actually. Okay. But that is anyway, that's a different altogether. That's an upcoming evolving era. All right. So now let's go to where we were for that matter, right? So let me pull up the PPT. Yeah, so some of these AI applications, you see, hope you see my screen definitely. So these are some of the object recognition. Okay. So there are two things actually. One is that about find out, what classification we are talking about, right? See the other is that I wanted to find out. So this is only more of, motor scooter, leopard, grill, mushroom, cherry, etc., etc. So this is object recognition. Now, this is image captioning. Next project is image captioning, meaning that whether human is there or not is this thing. But here I'm saying that man in black shirt is playing guitar. So this is next level. So here, whatever we have done now, right? The object recognition or image recognition of what is the distraction of the driver. But now here, now look at this. Whether a human is there or not, I can find out. Whether cat is there or not, I can find out. But black and white dog jumps over a bar. So this is very difficult actually. It's next to difficult. Meaning that you have to take out this, bars as a one image. You have to take out this as another image. And you have to take this position as another image and combine all these things and then get to the feeling of it. So actually speaking, these days, these things are not happening this way. This is more happening with the video analytics actually, because you'll not be able to find out the motion of this unless a couple of seconds of a video is there. But anyway, so I wanted to tell you that, yeah, there is another project, area is called as image captioning. Okay. This is object detection. In our previous pictures, right? What is that we are doing? If you go here, we see that this person is coffee drinking or not is all our classification. But I wanted to find out whether it has a steering, whether it has a shirt, or whether she has a earrings, or many objects I wanted to detect. Maybe it is useful for scanning the images. Sorry, what do you call as finding the tumors in the scan. So what is that we are talking about? This has an umbrella, this has a dog, this has a trolley, this has a chair, this has a bike, this has handbag, etc., etc., and this has a bench and all. So these many objects is what I'm looking at. Okay. So this is required, when looking at the billboards and all. So this is another business use case. Okay. So now these are all onto the images. Okay. Just simple object recognition, then image captioning, and then subset of images or subset of objects on a bigger image. Okay. Now text detection and retrieval. What is this? Let's say you are looking at this building. This is a mountain, or maybe whatever you can say. This is a building. You can identify. So this is a truck. Okay. You can identify this as a truck. But I wanted to read what is there on the truck actually. So what is that here? All we are saying is that find out the images. But here I wanted to get the name on that one. It is useful for the number plate recognition. For example, one of the very classic example, read the number plate for the distracted driver or anybody. Let's see if you can able to do this project, right? It's as simple as that. When people are passing the signal, the traffic police is capturing the photo of that number plate and to send the challan, right? Instead of that, your system can automatically do this one. That's fantastic. So that's enormous number of deep learning applications are there. Enormous. Yeah. Okay. So anyway, these are all, not these are all, some of the 4-5 areas of images. Okay. Now, another thing what we are talking about was NLP, right? What is NLP? Natural language processing. Anything deal with the text. So text summarization. So I give you this original, Alice and Bob. So now we are done with the images, introduction wise. Okay. Not the introduction, I would say the areas of the image classification again. So the point is, right, this has few dozens of different problem statement. This has a few dozens of different problem statements and the solutions too. So text summarization. Original text. Alice and Bob took the train to visit the zoo. They saw a baby giraffe, a lion, and flock of colorful tropical birds. So let's say this is maybe a two-liner thing. I'm asking for a one-liner. But I give you one complete book to you. Okay. Maybe Harry Potter, some series, number, etc., etc. Okay. Now I'm asking you, maybe give me a synopsis of this entire thing in 10 minutes of a time. So that is what I wanted to crisp and send it out. Alice and Bob visited zoo and saw animals and birds. This is summarization, right? So even the Gen AI is all based on this one, generative AI, where you give the very large language and find out the crisp from that. Okay. Now text translation from one to another text translation. Okay. Where are this? Yeah. So this is the another chatbots, right? You ask question in any format and get the response. And this is Yaren Haddad is one of the location where you can find a lot of AI applications, guys. I'll be sharing this PPT as well. Yeah. So this is where you'll be same like what you call as Kaggle. We also have a lot of AI applications in this one. Let me open this one. So 30 amazing applications of a deep learning. Okay, go here. Computer vision, pattern recognition, reenacting politicians, restore color in black and white. Okay, so lots of applications, especially specific to deep learning, are there here. Okay. All right. So now next is where are we? Yeah, let's move on. Yeah. So deep learning everywhere. So the mainly, in these days, people are using it for image of the, PET scan or MRI scans, X-rays, where you can just simply feed that X-ray and it identify whether this need a surgery or whether this has a brain tumor or not. If yes, what stage does it need an immediate surgery or late surgery, etc., etc. All can be done in the using the deep learning. Okay, security, defense, auto machines, quite not. Okay, so if you go here, sorry guys. So traditional ML, yeah, you will be doing the handcrafted. So the three areas, right? Vision, speech, and NLP. So vision has a two things again. That is nothing but images and a video. Both we consider as a vision only. Okay. So traditionally we find out the characters of each and everything, and then they say possible. But actually speaking, traditionally it is possible in the sense you have to spend, days of time. So that's where, how can we automate these features actually? So we have to convert all the images into pixels and then take the pixels as a feature and identify. So most important is the human brain understand the unstructured data by using a hierarchical representation. So we'll look into that actually. But what I wanted to convey here is that traditionally it is not possible. It has to be artificial intelligence based. Okay. So deep neural networks actually. So whoever is hearing the neural network as the first time, whoever is hearing neural network terminology as a first time, yeah, for you, you may go crazy. What is this neural network and all? So it's all simple. So, like, what do you call as 40, 50 years back, or maybe 30, 40 years back, there's all big data scientists and their art and deep neural networks, engineers, sorry, scientists and all thought that when a human is able to do it, what is machine learning? Human learning only, the decision tree regressor is there. It is a human learning only. But if you human has to do the Gini entropy prioritization of all these things, it takes enormous amount of time. We are using algorithms to find out that one. That is a machine learning. Similarly, why can't I do this for the images? If image has few features, maybe it has a car, etc., drink coffee, text, cell phone in this one. Why can't if human is able to identify, why system cannot identify? So that's the inspiration of a brain neuron. Brain is, our brain nervous system, right? So that's called a nervous system or a neuron. So the same neurons are, connected. Do you guys know how many neurons are there in our brain? I think some billions. Okay, let's go here. I don't know, remember what is exactly, but yeah, it's a few billions of how many neurons in human brain. Okay. Yeah. So 86 billion neurons are there. In the human brain, some 86 billion neurons from 100 trillion connections to each other. Numbers that, ironically are for too large for the human brain, for the human brain to fathom. So yeah, we have, that's why people say that, right, we'll be using only 2% of our brain actually. We'll not be using more than 2-3%. So meaning that, yeah, how much we learn, yeah, there is a scope for, accommodation. There is a huge scope for accommodation. So you don't worry, guys. It's that, we are learning artificial intelligence, a lot of stuff is there, it's getting exhausted and all. No, you are still using only, let's ask ChatGPT 1 second, just for the humors, ChatGPT. Bear with me 1 second, guys. Okay. Typically, how much percent of brain, human uses? Let's say ask that. What is say? Okay. The idea that the humans only use 10% of the brain is a myth. We actually use virtually all parts of our brain, and most of it actually almost same. So the turnover question is we use close to 100% of our brain, just not all ones. Okay, sorry guys, maybe I said wrong. So that's why modern brain imaging, etc. that shows that even during the rest of the simple tasks, multiple areas of the brain. So maybe it is about, the capability versus using. Using means maybe the what you call touching the brain of the part of the brain, maybe like this. But if what history says that, what science says that, now we use only, less than 10% of the brain effectively, but we still have 90% of the brain to utilize something like that. Anyway, so even I'm not clear. That's why I thought of just checking with you in front of you. But anyway, so the point is that, right? Yeah, our brains have not a lot of appetite to digest many things. Okay. So maybe it says that, every part of the brain will be touching something. Maybe you're watching a movie, still will be activating our brain and using the brain. But is that costly or effective utilization? It's a, chill style of using. So that is not what I'm mean to say that. Okay. Now let's go here. Yeah. So that's where the neural networks inspiration from the human brain. So that's where, going forward in the next class itself will be, starting on the same project using the neural network. Okay. So neural networks inspiration from the human brain could be used to automate feature extraction of unstructured data, guys. So we have unstructured data. So what is our goal? The immediate goal, if you go, where is my, this thing? Yeah. Data, we open. Yeah. What is my immediate goal here? The immediate goal is that how do I classify this person is, playing with the music system? I have to get the features. So we don't have features here, right? In the like structured data, we have features, but here we don't have that. What we have to do, we have to get the features from here. Maybe you slice this picture by 10 by 10. So which is nothing but 100 pixels. So each pixel becomes a, what you call as one feature. So the way you have to look into this one, let's say mesh, something like that. Okay. Or maybe let's say go to the Google and show me something. Mesh picture for features, something like that. I don't know whether this will give me or not. Let's go to this images. When I say mesh, it is giving all the other things actually. Maybe you can see that features from image, something like that. Let's see if this gives me 1 second. I'll not take more time. My intention is to show something actually. So what I wanted to say is that mesh on a picture for features. This is only what I want actually. If I go here, so what I wanted to apply something like this. Let's say I apply this kind of a mesh. I go and put this, maybe let's take this one. Okay, this one. I go and put this mesh on this image. What will happen? First feature, second feature, third feature, fourth feature, fifth feature, something like this is maybe 20 by 20. That meaning that I'll be getting 40 features from this picture. What is that? Maybe somewhere I'll be getting the nose, I'll be getting the keys, I'll be getting this fingers, I'll be getting the CD player or whatever the music system. So these are all nothing but my features. So eventually what I wanted to do is that in order you to identify this one, the first most important work is you extract the features from this image and store it in an Excel sheet kind of a thing. Once you have the features right, then it becomes a machine learning. So in a way, what you have to understand is that deep learning equals to feature extraction plus machine learning. Once the features are there, and because you don't have a features, my biggest worry, I don't have features here. These are all images. Now, if you can extract the features are nothing but columns, then you can apply something like a machine learning. See, it's not exactly as it, but I'm just opening your brain, stating that deep learning is feature extraction followed by some learning. That is nothing but what you call artificial learning. Artificial learning. Why artificial learning? Because it's not a human learning. Now let's go here. Where are we? Yeah. So that is where the extraction of the unstructured data features from the extraction. Neural networks with more than 3 level of depth is called a deep network and all. Okay. So this is how, this is exactly what I wanted to show you. So deep learning algorithms. So you'll be getting a raw data. I'm asking who is she? As simple as that, maybe I'll give you some politician pictures and ask you, please classify them. Who is Modi? Who is Revant Reddy? Who is CB Naidu and all, something like that. Okay, I'll give you some pictures. Identify politician or actor or the name of the politician, name of the actor, etc., etc. How will you get it? Obviously, you have to have the trained data. Without having trained data for Chandrababu Naidu, your system cannot identify the Chandrababu Naidu. So you have to have a trained data. So with that, see, this is what I am asking. First, you get the low level features. You get the middle level features. You get the high level features. So this same picture, so this is what I wanted to show you actually. Mesh on a image. So once you have these features, right? See, this image itself, you cannot find out what that image is. You have to identify the features from this artificial intelligence based image. Once you have these features, then you will see that, oh, the probability of having this eyes and this nose, this could be so-and-so lady, something like that. So deep learning algorithm allows the deep neural network to learn multiple levels of abstraction on unstructured data formats automatically. So that is what we are going to do it. So now the first step in our next class is that we take the project and we extract the features first of all. Once to extract the features, then we apply some deep learning algorithms and then go on. Okay. So why neural networks? So neural networks models could be used for the automatic patternization. It can be classification, regression, dimensional reduction, word embedding, likewise. Yeah. So move on. Yeah. So role of a data scientist must be bind these two networks, must care about the data and all these things. The engineers model AI. So education wise, so these are the things, but in startups, what they are using. Yeah. So there are so many, especially for the AI, there are lots of frameworks, guys. So the PyTorch is there from the Facebook actually. There is a cafe is there, one of the most again widely used one. Okay. These things are okay. These things are not very popular. But now coming to, yeah, this one, TensorFlow is from the Google, IBM Watson, CNTK is, cognitive native toolkit is from the Microsoft. Okay. So then there are some from the startups as well. Some people of the Java, what you call as community build something called DL for J, means deep learning for Java. So there is a chainer is that Keras is from the, again, this laboratories, one of the laboratories. Open Deep is from Virtuan, etc. So on and on, yeah, there are lots of data science frameworks, but IBM obviously they cannot use Google's one because they're all the competitors. Microsoft cannot use the Google's one. Facebook cannot use the other ones, right? So they're all anyway competitors. So on an average, the work-wise, it's all same. Syntactically bit different, the framework-wise different. Okay. So as part of the classroom, I'm going to teach you using the Google's Tensor framework. Like sklearn is a framework, right? So here for the deep learning, sklearn does not have the capabilities for the deep learning or artificial intelligence. We are going to use Google's TensorFlow. However, Google TensorFlow is very popular, being it's a Google and widely used one. However, this Keras is super, in a very short period of time, they got the lot of momentum. So what this Keras did is that wherever the reusable components or routine components, some common work, some cleansing of the data beautification, all those things, they have written a lot of APIs actually. So meaning that for any of the projects, right, you have to read the data, cleanse the data, extract the features, some of the common work that everybody has to do it. Whatever that common work is there, this Keras did that one. So that's why, and Keras ensure that they are supporting the Facebook code, they are supporting the Google's code, they are supporting the IBM's code, they are supporting the Microsoft CNTK code. So this Keras is compatible with any of these industry leaders actually. So what we are going to do, our application development is going to be using the Google's TensorFlow with the Keras as an API. So we'll be using these two things actually. So in the code, you'll see, sometimes you'll see from sklearn we said, right? We say TensorFlow, and sometimes we say from Keras. So even without Keras also you can build a solution, but you have to write 10 lines of code. If you, with the Keras, you'll be writing only 2 lines of a code. So that is a difference actually. So the point here is that, right, today I'll be teaching the Google TensorFlow, Keras, and image analytics. Tomorrow, if you are going and landing in Microsoft, Microsoft will not be using the Google TensorFlow because they are the competitors. They'll be using the CNTK only. But the same feature extraction, same neural network, the fundamentals are going to be the same thing. The syntax wise, but different. Maybe they'll be using comma separated or XLS, or maybe they'll be using some other thing, So that will be a small difference. Okay. So don't worry too much about these things. So that's why, right? If I have to teach Facebook, big sure, it will take 2-3 months. If I have to teach this separate, it will take 1-2 months. It will take another 2-3 months. It will take another. So you cannot learn each and everything. So it all subjected to, I'll put you on the track. Okay. And then you have to sail through it. So that's the way of learning actually. Okay. But anyway, we'll be using this Google's TensorFlow and the Keras for their image analytics project. So where do you, deploy them? So there are some, for all these images, right? The CPUs are not enough actually. We are using normally CPUs for our machine learning. We have GPUs, graphical processing units. So most of your laptops, I mean to say whoever don't have the GPU laptops. So I'm sure assuming that most of us, our laptops are CPU based. You say i3, i5, i7. So that kind of, they're all CPU based laptops. So in the CPU based laptop, because it is all graphic images, right? It takes time. So that's why you need a GPU. With a CPU also you can run it, but it takes enormous amount of time. So there are some GPUs, NVIDIA, Titan, Jetson, Tesla, Drive, PX, Titan, Tesla, these are all some of the, GPUs actually. So you can use any of these GPUs. So one is that you can buy GPU based laptop, usually anything more than 1.5 lakh, 1 to 2 lakhs you will spare. And then you get a GPU laptop. Again, there are a lot of NVIDIA, Jet, segmentations are there. Like we know about i3, i5, i7, Ryzen, etc., right? Celeron, whatever. So there also different stuff is there. But however, yeah, don't worry that. So Google is providing something called a collab. Okay. Google collaboratory service. If you go to Google Colab, so they are giving the free GPUs. Okay. If you go here, let's say, just bear with me 1 second. Cancel. So now there is a runtime here. Change runtime type. So you'll be saying that T4 GPU, V28 TPU. TPU is nothing but central processing unit, graphical processing unit, tensor processing unit. So you can use this one and run it. However, we can get this for the free of cost. But let's say you want some parallel processing. Okay, meaning that I want to run my application 10 processors at the same time. And maybe here they are giving a T4. T4 is the okay in terms of a GPU actually. So it's like maybe i3, i5 in terms of a GPU. But if you have this L4 GPU, then V 8800 GPU, they're all sizable actually. Okay, there you can also purchase. Let's say you really wanted to do bigger work and all. Yeah, here they'll be giving, look at that, 100 compute units per month. Here they have you currently have 0 page as you go kind of a thing. Faster GPU, more memory, terminal, you can have your own terminal. Again, so they have given light of 500 limited time, 500 compute units, faster GPUs, dedicated. See, look at that, mainly background execution will be there. So generative AI application support and all. So maybe you can start with it, the P as your normal one. And when once you just look at that, maybe you can start with only the simple one of $12 per month and use this one. So you'll be getting 100 computations and the faster GPU, more memory, terminal, you'll be getting your own VM and all. So this is always the simplest option than buying a new, what you call as a GPU. Okay. Now, where is that? Yeah, a lot of, yeah. Okay, anyway, so let's move on. Magnifier. Yeah. So these were the GPUs. Okay. All right. So ignore this syllabus and all, guys. Okay. Yeah. Uh, yeah. So now I'm going to do, and this is the journey of the AI world, right? So this is how we started this way, and this is the robo. Okay. One of the very classic example. Okay. All right, guys. Any questions so far? Okay. So now, as part of the classroom, so we will be taking this project. Okay. You go to Kaggle, dogs versus cats. So as a seems to be, okay, let me ask you this question. Instead of I tell this answer. So here they have go to all it is that go to the data and download the data, download all. Yeah, it's downloading, but I have already downloaded the data. Yeah, it's a big, all this, any images and all will take time actually. Data science, data. Yeah, cats versus dogs. So now if you go here, train. So they have again given the cats and the dogs. Okay. Here, look at this. So cat is cat, right? So it's like, one classification. So they have given all the cats. But here important thing is that, look at the data, guys. The cat is not like, passport size photo. People, they stand, their background should be white color and you should stay focused. Look at the front camera. It's not like a photo studio. You go to photo studio and they take passport size photo for your passport application. It's not that good quality images or anything. Look at this, right? This one, look at this. So maybe, you cannot even, what is this? This, my image recognition will recognize that, lady face rather than my cat face, right? So look at this. So look at this. I never anticipated two cats in one image, right? So now this lot of head has gone. Okay. So now look at this, right? These are all, can't even think of it. How do I know that there will be a grill in front of a bar, in front of a cage, in front of a cat, and I should consider that as a cat, right? So this is how, group of cats. Okay. So likewise, I have, this is a reverse facing and etc. etc. Okay. So these are all my, what you call as cats. So they have given the cats and also now they also have given the dogs. Okay. Look at this. Yeah, I'm not opening each and everything, but you see the style of dogs, how they are. Some of them are zoomed out, zoomed in, shot from the near vision, shot from the distinct, shot from the corner, shot from the. See, look at this. Unless and I open very clearly, I don't know this is a dog or not, right? Let me open this out. I don't even consider that to be, this side face dog and all, right? Bit complicated data. It is not very straightforward. People shot it with the background of as, one standard, not like a passport size photo. If the things are taken like a standard passport size photo with the standard dimensions and all, the project is simple. But this is a very tough project. Okay. Now, after that, you go to the test data. Where is my test data? So within the test data, I'll be getting the combination of cats. Guys, if anybody is not understanding, all I'm saying is that in the image analytics world, in the train data, you'll be getting the data in the classified folders. In the test, you'll not be getting the classified folders. Now, what is our goal? What is image 1? You have to find out. What is image 2? You have to find out. What is image 3? You have to find out. Okay. What is image 4? You have, okay. This is a cat. And then image 17 is a dog. Okay. And image 27 is a dog. 26, 24, 23 is a dog. Okay. Etc. etc. Okay. Now, this is the project that what we are going to work on the upcoming weekend, guys. Okay. We can finish this project in the upcoming Saturday, Sunday. Okay. You cannot afford to miss the class. We will finish it off in the class. Okay. And also that's where we'll be showing the Google TensorFlow and all those things. Now tell me, guys, everybody, is there, after looking at the distracted driver detection of the state farm company versus this dogs and cats project, which one seems to be complex, guys? Dogs versus cats or distracted driver detection, which seems to be tough project? Which is a tough project out of these two? Guys, please. Okay, let me. Ashrita, Harika, Dinesh, Aditya. Which project seems to be tough among these two? Preetham, Preetham. Okay. I think cats versus dogs because multiple features need to be captured. Okay. Preetham, Bharti, Ravikant, Dinesh, Ravikant. Cats versus dogs. Praneeth, thank you. Okay, others, guys, two, three other responses, please. Sudha, what do you think? Which one is complex? One more response, guys. Vicharan. Okay. Uh, Ravikant, there is no disaster recovery as such. There is no disaster recovery. Distracted driver detection is there. Okay. Yeah. Uh, Distracted driver. Okay, good. So anyway, so couple of guys said distracted, couple of okay. But yeah, answer is actually Harika and Praneeth. Yeah, card caption versus are the complex. Sricharan and Ravikant. Yeah, don't think that it has seven feature, what you call 10 different classifications. It is difficult. The biggest thing is that there it's easy to see. The point is that, right? What are the features for the cat and dog? Same legs, four legs, two eyes, and a lot of features are same. Okay, and it's very difficult to get this, and the data is also very clumsy actually. Whereas coming to the our distracted driver detection, right? The data is sober actually. The data is, look at this. We are talking about music system, reaching to the music system versus what you call as the other category is cell phone. Completely different, right? There is no cell phone in the hand of this person. So it is easy to recognize. Okay. Coffee drinking is one of the distraction. Coffee cup versus having a cell phone to the ear versus texting versus reaching to this, this one, or maybe some of the what do we got it as, reaching behind the seat and all, right? They're all very easy to identify comparing with the two features from two animals. Okay, so this is the reason why I'm asking the question. So business wise, I agree that this is a more business useful case, because yeah, it is giving no insurance companies premium to be find out. For the in terms of a business, this is a great project, but for the learning purpose, this is definitely, undoubtedly, there is no near and dear. It is undoubtedly very complex project compared with that one. Okay. Only thing is that, yeah, when I say that cats and dogs, in the interview and all, yeah, it doesn't look good, right? But what I'm saying is that as part of the classroom, we'll be doing this one, but you can convert, distracted driver detection as your project into your resume or whatever it is. Okay. Right. Sri Charan, is that clear? Sri Charan. Okay, Praneeth. Yeah. Yeah. Hanika, even your answer is even sober. Yeah. Because it has multiple feature needs to be captured. Right? Okay. Right. Move on. Next is, okay, guys. So next is coming to the some so next week basically, yes, we will be working on this one. Okay. Now let's move on. Very interesting, guys. Actually, yeah. It's just that your focus has to be stay tuned for the 2 hours of everyday class, every week or whatever, Sunday, Monday, and do some practice and explore the other things. Listen to the recording, or maybe take some other project from the Kaggle. Dedicate, like assuming that this is one 3 months semester kind of a thing, spend good amount of time, right? Then it's good actually. See, you cannot say that, no, I don't know voice recognition project answer. If you are good at, 3-4 projects, which is much more than anything actually, right? So a lot of times, training, what will happen is that people say a lot of theory and at the end they say that capstone project. Unfortunately, you don't know what is that capstone project. Whether you'll be doing in classification or regression or image analytics or NLP, which God knows actually. And if you become expertise in NLP, doesn't mean that you are good at the image analytics at all. It's a different topic, different module, different altogether specialization. But all comes under the data science or AI ML as the world. That's all. Okay. Right. So now next is okay. So I'll take some time to okay. So going forward, what we'll be doing is that here we don't have to what you call as download or any of the software. So let me go the prerequisites. Let me write the prerequisites. Okay. Requisites. What are my requisites? Requisites for DL/AI. What are my prerequisites? One is that we need Google's TensorFlow. Okay. Keras API framework. Okay. Now we need GPUs. And the coding is going to be Python only, guys. Coding is going to be through Python. Okay. That is going to be Python only. So these are the things what we need it actually. Okay. So let's go. Yeah. Now, Google's TensorFlow, just for the sake of, I'm just going here, Google TensorFlow. Very powerful, very, very, very powerful. You'll see some TF as a logo and all. Very powerful. Yeah. So, an end-to-end platform for machine learning and the deep learning. So you see that, down somewhere. Yeah. Join the community and all these things. So you can also install all these things. You can go and install, provided you have the GPU system. Okay. Now you go here. TensorFlow is a software library for machine learning and artificial intelligence. It can be used across a range of tasks, but it is used mainly for the training and the inference of a neural network. It is one of the most popular deep learning framework alongside others such as PyTorch, etc., etc. Okay. So if you have your own laptop where you have to install the TensorFlow, if you assume that you have a GPU and all, you can install. You go here and see install. Now the other one is that Keras, keras.io. Okay. So Keras is an open source library that provides a Python interface for artificial intelligence neural. Keras was the first independent software, then integrated into the TensorFlow. So that's what I said, right? We'll be using TensorFlow with Keras. So it is integrated into the TensorFlow library and later added support for more. So from outside world, you will not see that Keras as a separate, though it is an open source built by a startup company and all, but it is now supporting this one and programming language same Python only. Okay, actually group of people who were part of the TensorFlow, they came out from the Google and built this one actually. So they found, hey, a lot of times data scientists have to write, these are the standard codes and all. And then they added, welcome to a multi-framework machine learning. Yeah, they say somewhere, yeah, here, look at that. It is supporting the TensorFlow as well. So it is, yeah, API documents. So they are providing all the API, you see, merging of layers. Let's say you have to merge 2 layers. You have to normalize some layers. You have to pool some layers. So pooling of a layer, everybody has to do it. Okay. For that, you have to write 10 lines of code. So they have given, that entire thing in one API and you can use that one. So we say that keras.pooling maximum pooling of 1D. So that will do our entire work. So anything that you think the routine work, sorry, repeated work, they made it as a framework and gave it to us. So this is one. And then what is the other one? Python. So we have to install Google TensorFlow, Keras, and then framework, and then GPUs and Python. Python is also what we have installed. So instead of that, so this Google's Colab is there, right? Colab. So this is on what? It is on the cloud. So we are not doing this on the your local. It is on the cloud. Okay, it's on the Google Cloud. Colab.research.google.com. It is on the cloud. We are not doing it into our local. So we go here and see that image classification, something like that. You go here, and at the moment you are running this one on the cloud, when you are running this on the cloud, or you can go and select this one, change runtime type to whatever the available GPUs, etc. And then they save. Now you go and say run each and every cell. It is automatically running in the Google Colab where TensorFlow, Keras, Python already installed, because you are not running into the what you call as your local. You are running in the cloud actually. Because you are running in the cloud, it is by default, the cloud has already pre-installed with the necessary softwares. So you don't have to. If you have a GPU on your local, you can go and download the things. But otherwise and all, you don't have to worry about like how we did the Anaconda distribution package in your local and did it. So this is all be already pre-installed into the Google Google Cloud. Okay, but if not, yeah, even if you wanted to test it out, you can go to what you call as yeah, I have a lot of windows open. Sorry, guys. Yeah, you can go here and then download Google TensorFlow download. Yeah. Yeah, you can go and install TensorFlow 2 is the latest version. Yeah, so this is what download this. You can download this one on your local. Just for the sake of you can do it. Okay, no problem. See, even with the CPU also we can run it. It takes only the time, nothing more than that. And also you can go to the Keras install. Yeah, you can, because it's a Keras. You can also do it from the after you install this one. You can see pip install Keras. It's a small. It's not a very big framework like a TensorFlow or anything. It's a small one. You can install Keras from the pip itself. That will serve. But only thing is that when you install the Google TensorFlow, right, you have to put it in a different environment. So you should not mix with that your machine learning to this one. So that's a small. Ensure that this is using some library, different libraries, that is using a different libraries. So it's up to you how you want it to be, guys. In Python is anyway there. I'm sure as part of the Anaconda it is already installed. So you have to install TensorFlow and Keras from the Python. Shell command prompt, Anaconda prompt, pip install. So this pip install, so now you go here, you can see something called the TensorFlow. See, you can see TensorFlow here. Oh, okay. I don't, because I'm using the cloud, so I have not installed, I think. Hold on. Yeah, usually, yeah, it is not there. Best match is only there. Yeah, it is not there. Okay. So I have not installed because I'm a fan, not a fan. I usually use because mine is only CPU based laptop. I'll be using a Google Cloud because it's very simple. We don't have to install anything. You can straight away get to the program. But anyway, if you wanted to download, you can download and install. Okay. And when you are installing the Keras, you have to install on the TensorFlow environment, not on the sklearn environment. That's only the small thing that you have to remember. Okay, right. Are we good, guys, so far? Okay, now I'm in this next 15 minutes or so. I'll just give you a quick introduction of to the neural networks, and then we are ready for our coding in the next class. Okay. Right. So this is again, you go to internet and see the moment you say introduction to neural network or introduction to artificial intelligence, you will see this picture first of all. Okay. So neuroscience at UTH from one university. So basically the point is that, right, the neural networks or the artificial intelligence is the inspiration from the human brain. And this is what the human brain is actually. Okay. So we are not going to the very detail of it one, but our brain nervous system is impulse carried away towards a cell body, dendrites, nucleus, cell body, axon, branches of axon, impulse carried away from cell body and axon terminals, etc., etc. So this is how human brain nervous system or whatever, I'm not a doctor or anything, but yeah, that's how our biological neuron is being designed, our biological neuron is like this. So the biological neuron is the more of a scientific terminology. And whereas coming to our data science, we call this as a neural network / we go internal and say we call it a perceptron and all. We'll talk about that in a minute. Okay. So now if you go here, so this is how you have to think first of all. Okay. I'm sharing my one of the typical neural network. Okay. So what does it mean? What does it mean? If you go here, 1 second, where is that? Yeah, lot of shut. Okay, accidentally click something. Okay, maximize. Yeah. So if you look at here, right? Every picture, first of all, what you have to do, you have to extract the features. How to extract the features? I have shown you, right? You have to put a mesh on top of an image. And it's like a pixels, right? You say my picture is of 100 70 by 70 resolution, 30 by 30 resolution, something like that, right? Some resolution of some photo terminology and all. So once you have those features, assuming that for my cat, I got 7 features. Okay, actually 7, you'll not be getting 7 features. Even if you convert it to 5 by 5 image, it will be 25 features. If you say 25 by 25, 125 features, 125 by 125, then you'll say, 1025, etc., right? 1125 and all. So those are all nothing but my features. See, eventually, what is that? No system is going to find out simple cat or dog. Nobody knows. The idea behind that is that you have to extract the features and feed those features. Now that we call it as an input layer. Okay. It is an input layer. This entire neural network works on y equal to mx plus b only, guys. Okay. That's why we have introduced that yx plus ms plus b in a regression also. So what is my y here? This is my output, whether it's a cat or a dog. That's all my output. Here it is a binomial classification, but if it is a multinomial classification, you'll be having more outputs, maybe coffee drinking distraction, or what you call as talking distraction, texting distraction, and then reaching to CD player, music system is a distraction, reaching behind seat is another distraction likewise. Right? Now, these are all nothing but my input layer. You know the input layer of 25 features or 125 features, whatever X by Y features, and this is what my target. But from this to this, is that happening straight away? No. I am feeding to my brain. When you look at this, this is how you have to think it, right? I'll tell you one important thing, guys. Try to understand this one. Think of this one. Now let's go here. Sorry for sidetracking. If you go here, let's say, if you go here, this is a cat, right? Think of this one. If you are a 1-year-old baby, today you are 1-year-old baby, okay? Can you identify what is this? Assume that a newborn baby is a 1-year-old baby or few months baby is there. Can he or she identify this is a cat? No. Her mom or his mom, that baby's mom, tell you that, see, by showing that this is a cat, something like that. Okay. So think of this way. A newborn baby is not able to find out whether this is a cat or not. Okay. Similarly, now I say, see creatures. Okay. Now let's go here. Images. Now if you go here, let's say here, open this one. 22 types of sea animals. Okay. Now, can you tell this as maybe what you call as squid? Do you know this as a squid? We don't know this as a squid. Maybe some of you know, maybe who are know about Noah. This is an eel. Okay. This is manta ray. Do we know this is a manta ray? We don't know this is a manta ray, right? So now the way you have to think is that I'm giving you, instead of a cat and dog, I'll be giving these fishes as a train data, and I'll be giving these similar to test data without an output. How will you be doing that? Oh, manta ray will be having some kind of a, what you call as some shape with some ray and some, some of these things, something like that. Some kind of, how will you say that this is a manta ray? I'm telling you that this is a manta ray, and tomorrow I'll be giving you another manta ray, and you have to identify manta ray. What is your brain working, guys? Oh, how will you say that? Okay, this is of XY shape, maybe square shape, or maybe with the two wings or something like that, or two eyes and two these things, and then you consider this as kind of a manta ray, right? How do you see that this is a seal? This has, maybe tall, lengthy neck and something like that with a triangle shape face, something like that. Then you call it as a seal. Now you go and see that manta ray, right? Now you go manta ray, see creatures. Okay. Now let's go here. Look at these images. Manta ray. So all these are manta rays, right? But we don't know manta ray in general. This is not a usual name. I don't know. Okay. But you learn this few hundreds of images as what you call as train data. Then if I give you tomorrow another manta ray, then you will be able to identify. So in order to understand the data science, you don't think that you know about a cat and dog. What is their difficulty in finding a test data as a dog and cat? You always know entire your data science lifetime. You should remember me about this one. Sir taught me about the sea creatures by showing the sea creatures, and do I know all of those sea creatures? I don't know all of those things. Then how will I identify the test data? Oh, that's the problem actually, right? So what is that I'll be doing? Your brain is immediately slicing this into some features, but it is happening in a fraction of time because our brain is superpower brain. You are converting this into lot of features. What are those features? High level features, mid level features, low level features, right? So in the PPT we were talking about, right? Somewhere we were talking about the features. Yeah, there are lots of files I have opened, but anyway, so you're converting that features, you're converting that image into features, and then you're combining those features and then identify that, oh, this is manta ray, not a jellyfish or not a catfish, right? So that is exactly is what we are going to do as part of this one. Why did we come there? What is my input layer? I am converting this manta ray into 25 features. What are the 25 features? This is one feature. 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 I'm feeding all those features to this one. Eventually, I want whether it's a manta ray or cat or a dog or maybe a jellyfish, catfish, something like that. But that is not happening from your brain to output just like that. The lot of hidden calculations are being happening in your brain. What is that hidden calculation? So if you go and read neural network, you go crazy, you feel like understanding, you don't understand. But I'm giving you some idea for that. Okay. What is that? Okay. This is one feature. This is one feature. This is one feature. This is one feature. This is one feature, right? But what is the most important feature out of it? Oh, think of this, right? Assuming that this has a 25 features here. I'm just slicing this into 5 by 5, 25. But do I need all 25 features to identify this is a manta ray? No. Maybe this is an important feature. 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 Maybe 10, 15 features are important to find out this is a manta ray rather than all 25 features. Or think of this, I'm converting into 100 by 50, which is a 500 features. Do I need all 500 features to identify this as a manta ray? Maybe 100 features are more important, right? That is nothing but this one. In the hidden layers, what we'll be doing? You take this x-axis, x1 feature multiplied by 10. You take this x2 feature multiplied by 5. You take this x3 multiplied by 7. You take x4 and multiplied by 6. You take this one and multiplied by 7. You multiplied by 1. Why 1? This feature I don't need it. This is where some wing with a plain and simple. This is not really matter for me. It is a matter if I'm not able to recognize in the first hand, then I can go into the deeper networks. But at the initial, my importance is I wanted to give some importance to 1, 2, 3 feature, but not 4, 5 feature, but medium feature to 6 and 7, something like that. I go and multiply this with this some number. Then that is nothing but y equal to mx. So m into x1, m into x2, m into x3, m into x4, m into x5, m into x6, m into x7. Plus, I'll be adding some bias to this one. Each and everything. Whatever I try to do it, I'm not getting my Manta ray. I'm getting something else. Now what I do? Oh, with my one layer, so think of it, right? I'll show you maybe one classic example. The way you have to look into is that one. Maybe next class I'll show. No problem. Yeah. So then we get derailed. That takes more time. So you'll be looking at this at the first shot as maybe you'll identify this as a creature in the first shot. Then you'll identify this as a manta clay. Then you maybe another manta ray versus some other classification of sea animals, and then you say this one. So what eventually typical neural network is nothing but, so I'm going to the next level. Okay, the details of the previous picture. What is the details of the previous picture? Okay, now this is the length of this, width of this, some petal length and the petal width, assuming that. Okay, maybe I'm taking the only 4 features. Now I'm multiplying this with the some number 0.02 something. I don't know what that number is a random number that neural network will give. And this will be fed into 3 neurons of my hidden first layer. Again, this will also be fed into these 3 things. Again, this also will be fed into these 3 things. This also will be feeding into these 3 things. Meaning that 4 features will be feeding into 3 perceptrons. Perceptron is nothing but a neuron. Neuron is a biological term. Perceptron is a data science term, guys. Neuron is a biological term. Perceptron is nothing but, this is a neural network with one input layer, one hidden layer, one is output layer. With these things are nothing but a perceptrons. So once you come here, right, whatever you try to do it, it is not satisfying. You're adding this blue color as a bias. What is that bias? In the picture, you may get confused. Yesterday, we talked about when we are talking about the maintenance of apartment, right? It says that 2 BHK, 2,500, 3 BHK, 3,500, 4 BHK, 4,500. That 500 is nothing but extra value multiplying by 100 plus 500. So that is nothing but this one. Now here, are we able to capture whether it is yes or no? It is not. Then we go to the next layer and then we see that this is a manta clara, this is a catfish, this is a jellyfish or something like that. Again, we are also adding this thing. After all doing this, right? Again, we'll be saying that how much is the loss, meaning that manta clara is classified as the jellyfish, jellyfish is classified as the human being is classified as a sea creature, etc., etc. So, meaning that, so eventually, first journey of any neural network is that you have to identify the features, feed it to the input network, build a neural network with the 2, 3 hidden layers. Within that hidden layers, some process is going to happen. You have to adjust the weights. What do you mean by weights? So that weights is nothing but this one. Some number, yesterday we said, right? Lot frontage into 100 plus number of bedrooms into 200 plus lot size into 300 plus some bias is equivalent to sale price. Here also, each and every feature you are multiplying with some number, random number, and who will create that number? As a human, it is next to impossible. My deep learning framework is going to try with some number and do 100 trials until it get to the closest possible. It increase or decrease the weights. So don't get confused that, sir, all of a sudden brought in weight word. Where is that weight? No. We also taught yesterday the same thing. Weight. Lot frontage into 200 plus number of bedrooms into 300 plus Swimming pool into 100 equivalent to sale price plus B 500. What is that? B is nothing but your what you call it, bias slash intercept. Then we call that as a sale price. So here also my varicolour or Virginia or Setosa or some of these flowers, but these are getting classified by length. If the length is of multiplied this one plus width is this one, length is this one, width is this one, then you process and then you get something like this. So this is a typical what you call as a neural network. Let me just put some of these sample networks in the chat. Flash. So what all the terminologies that we use today? If you look at here, yeah. So terminologies, what we talked about. Yeah. If you go here, deep learning, AI, okay, object detection, image detection, image classification, computer vision, okay, image analytics. All are same actually. There's a lot of confusion in the world, in the industry. Image analytics, then basics of only. I cannot just say neural networks. Okay, neuron is a biological term. That's now we say that perceptron is a DL terminology, which is equivalent to biological term neuron. Okay, and now input layer, hidden layers, and output layer is a typical neural network. Okay, here important thing is hidden layers, guys. Layers. Okay, a typical neural network. Okay, yeah. Now feature extraction of an image. Okay, sample projects. Okay, cats versus dogs and distracted diver detection. Okay, what we call as TensorFlow and other frameworks. Okay, other AI frameworks. Okay, bear with me 1 minute, guys. Okay, Keras, and then GPUs, Google Cloud, etc. So these are all the some of the buzzwords that we talk today. Cheat sheet. Yeah, copy this, guys, as a cheat sheet. Download this 2 images. Okay, and this one, Yaran Haddad, go there, spend some time. So the 2 hours of class, right? What we're talking, you have to at least spend 3-4 hours of on this one. Okay, yeah, guys, whoever we have done in today, lot of stuff. If you just start digesting or injecting this kind of things into your brain, for 2 hours on a daily basis of a quality, diversified, knowledge, yes, you can be. Nobody can touch you actually. Okay, all right, guys. Thank you. Take care. Bye.